Now, on number 9, you're told that, of course, you know that we have this fundamental equation, VF equals V naught plus A delta T. And this just represents the definition of average acceleration, which is change in velocity, which would be V minus V naught divided by delta T, which is exactly what you get if you solve this for A. So this is just a rearrangement of essentially the definition of uniform acceleration. Now, we also know that the acceleration would be equal to F net over m. Assuming we have a constant force F net, you're going to get a constant acceleration on a given mass, force applied to the mass. Okay, so in this situation, you're simply asked to go ahead and substitute A equals F net over m here, and then solve the result for F net delta T. Well, that's quite easy to do. We substitute A equals F net over m, and we get this. We see the F net over m sitting here where the A was previously. And then we solve for F net delta T. It's very clear that if we're wanting to solve for F net delta T, we can first multiply both sides by m, and then subtract the mv naught we get here, or alternatively subtract v naught from both sides, then multiply by m. Doesn't matter. Either way, well, I've done it this way. I've multiplied by m before doing any subtraction. I've got mvf equals mv naught plus f net delta t, very clearly what you get when you multiply by m. Then I've subtracted the mv naught from both sides. So f net delta t here would be mvf minus mv naught. And we can say that that's a change in what quantity, because that's the way the question was phrased. What's that the change in? Well, people want to say, well, that's a change in velocity. No, mvf minus mv naught is not the change in velocity. Now, it's velocity that's changing, so it's not surprising that you would focus on that. But it's the quantity mv that's changing. Okay, because we have mvf minus mv naught. Yeah, I mean, you could say that f net delta t is m times the change in velocity if you want to. That would be perfectly valid. But what is f net delta t equal to the change in? It's equal to the change in the quantity mv. It's the final value of mv, which is mvf, minus the initial value of mv, which is mv naught. Now, the problem 10 asks you to do exactly the same thing, but with a different equation. The equation vf squared equals v naught squared plus 2a delta s. Okay? The algebra is almost identical, and the result is very, very similar, except you're going to have squared velocities instead of first powers, and you're going to have a factor in there. So you need to work that through and see how that works out, and maybe see then what that might have to do with problem number 8, and how these 4 questions, oh, well, this one isn't really completely relevant to either of these, because we haven't talked about f net delta t, which is something we call impulse. So, problems 6, 7, 8, which you haven't yet done, or maybe you have, but hadn't yet as of class time, and 10, which really tells you how 8 is related to 7, and 7, of course, is related to 6. So you want to see if you can understand the relationships among those. 9 is thrown in there because it comes out at the same time as what you get in 10, and it's something that we're going to talk about as well. And there's an important distinction between the quantity mv and the quantity that's changing in number 10.